Hey, what's up? It's your old pal, Mr. Cook, and we are going to be working on the 6.5 to 6.8 quiz review worksheet. Okay, so for these problems that we have, numbers 9 through 12, and really all the way through number 20, we're going to be solving logarithmic expressions and exponential expressions. And the best way to do that is to remember a really commonly used property that we've had, and that's the ability to turn from an exponent into a logarithm and vice versa. So I'm just going to write that over here and put a box around it. Because if I have an exponent, a to the x power equals y, I can rewrite it as a log, and it looks like this. Log with a base of a of y is equal to x. So I just rewrite it. Those same exact letters go here, but I solve for different stuff. And then the other thing that we're going to need aside from this, really just a way to rewrite logs as exponents, is just a calculator. If you have a scientific calculator, it works just fine. Or if you have a graphing calculator, it'll work real well too. So either way, you should be able to get these answers done pretty easily. All right, I'm going to actually use probably, let's see here, I think I have a really crappy scientific calculator just to show you that even those ones work just fine. Whatever, I can't find it. Let's use this one. Well, just familiarize yourself with where the log button is. Like on one of these calculators, the log button is over here. So, we'll use log a lot. So just press log, and then we also have natural log, which is right below it. That's when the log has a base of an e. And then in some of these fancier TI-84s, you're gonna be able to press the math button and then press up a couple times, and you'll see a function log base. It's not in all of the TI graphing calculators, but you'll be able to write out a logarithmic expression just like that. It's pretty easy. But anyways, so we're going to be using this sometimes, and if you need a little bit more of a refresher on logarithms, just make sure to check out the previous quiz review. I think I went over some of that stuff as well, like some of the properties and stuff, so check that video out if you need help just typing them in. Anyways, so what your goal is with these problems, numbers 9 through 12, when you have an exponent, you want to isolate the exponent so it's all by itself. So notice a problem like number 12 and number 10, you have some extra crap that's going on outside the exponent, and number 11, you need to isolate the exponent by itself. So, in each case, circle your exponent just by itself. Don't include any of the minuses or multiplication on the outside. So if I'm just circling the exponent, that's all I've done for 9, 10, 11, and 12. My goal is to get that exponent by itself. So in this case it is. In this case it isn't in neither of the other ones. So if it's not by itself, get it by itself. So if I have to get rid of this minus 3, how do I get rid of subtracting 3? When you're solving, you get rid of minus 3 by adding 3. So I'm going to add 3 to both sides, and that gives me 20 to the power of 8x minus 8 is equal to 33 plus 3, which is 36. All right, so now I have the exponent isolated by itself, and I'm ready to move on to the next step. I'm going to do that for all of these real quick, just to show you that it's the same step every time. To get this exponent by itself, I need to get rid of minus 2, so I'm going to add 2 to both sides. So then I get 6 to the power of 8 minus 10x is equal to 92 plus 2, which is 94. Then I got some other stuff that I got to do here. I got to get rid of this plus 7, so I subtract 7 from each side. And I get negative 2 times 5 to the power of negative x minus 1 is equal to, and then negative 67 minus 7 is negative 74. And then I still need to do a little bit more because I got to get the exponent by itself, so I need to divide both sides by negative 2. And I get 5 to the power of negative x minus 1 is equal to, and then negative 74 divided by negative 2 is a positive 37. So that would be my answer so far. Now that I've got the exponent all by itself in each of these cases, I'm going to use this property of turning an exponent into a log. The reason that I do that is because I'm solving for the exponent power. So to get the exponent power by itself, I need to turn it into a log. But watch what happens when we do that. It actually gets really, really easy. So just using the transformation, transformation of going from exponent to log, I rewrite this as a log, and it looks like this. Log with a base of 20 of the number 89 is equal to 9x minus 6. Now, if you type this into your calculator, it's just going to be a number. So, if I have one of these fancier calculators that does the log base, I just type it in, 20, and then 89, and I get, that number. That's what this is, 1.4983 is equal to 9x minus 6. But then, if you don't have one of these fancy calculators that does the base, it's okay. You can just do log of, log of the number that's in parentheses here, 89, divided by the log of the base. So the log of the base is 20. And if you see, like if I type that in, I get the exact same number. See, so it's a couple different ways to write in your log on your calculator, but it still does the same job. Okay, anyways, now that I've got this number by itself, I need to get x all by itself. So what I need to do is get x by itself, so I add 6 to both sides. So I get 7.4983 is equal to 9x. Then I want to get x all by itself, so I divide both sides by 9. And I get my answer. X is going to be equal to some approximate answer. Let's see what it's going to be. So that plus 6, and then divide by 9. I get 0.833. I need to go to the 10,000ths place, so that's tens, hundreds, thousands, 10,000. So that's 4 decimal places, so that'd be 0.8331. And there's my answer. And just to let you know, these are always going to be handled the same way. You turn each of these into a log and then solve it. So this one written as a log is going to be log with a base of 20, and then of the number 36 is equal to 8x minus 8. So I'm going to just kind of remember that this is just going to be a number. And what I'm going to do is just get x by itself without using my calculator just yet. So I've got this number, and then to get rid of this minus 8, I add 8 to both sides. So it's going to be 8 plus log base 20 of 36 equals 8x. And then to get x by itself, I divide both sides by 8. So let's do this number on our calculator, because that's what x is going to be equal to. So we have 8 plus log base 20, 8 plus log base 20 of 36, and then divide that number by 8, and you get your answer 1 point, and then we got to go to 4 decimal places, so 1.495. There we go. Okay, so quite similarly, we're going to keep solving these ones. So I turn this into a log. Log base 6 of 94 is equal to 8 minus 10x. So to get the x by itself, I need to subtract 8 from both sides. So that's going to be negative 8 plus log base 6 of 94 equals negative 10x. And then I divide both sides by negative 10. And I get my answer for x. Let's see what we get. So negative 8 plus log base 6 of 94. And then I divide that number by negative 10. And I get my answer. And I go to 4 decimal places for this one. So 0.5464. And there's my answer for number 11. Number 12. So write it as a log. Let me put that over there in case you're writing down. So log with a base of 5 of 37 is equal to negative x minus 1. So I add 1 to both sides. So 1 plus log base 5 of 37 equals negative x. And then I divide both sides by negative 1. And that gives me my answer for x. Let's see what it's going to be equal to. So 1 plus log base 5 of 37. Oops, don't need that in there. So 37. And then divide that number by negative 1. And I get my answer, negative 3.2436. There we go. That was a bit of a stretch to write that down, but I got it. Okay. So that's the end of the solving the exponents, and this is stuff I believe is found on 6.6. So if you need to check that out, go ahead and practice some more of those problems from your worksheet packet. And then we'll move on to these next problems where they're all a bunch of logarithms. And I think I'll do that on a separate video. So that's it for this video, and then we'll move on to the next one.